is on this portion. Basically here we simply looking for is a response in this case. Okay, so this scenario. This is applied force, and that we take the unit, the initial, the small strip here. And then follow up, we define such a small strip as an impulse function. Okay, so the system's response to the impulse function we know in concept is something like this one. So eventually we lead to the discussions of the system to unit impulse, and we have the whole blown through description here. The concept is this: when system take up the unit impulse, it's going to have the change in the velocity. So that means this, we have this one here. So with this kind of generic calculation in mind, we lead into expression for the unit impulse function or the unit impulse response like this one. Okay, and then for general, the system response to the general impulse function, which doesn't have to be unit. So here has a magnitude that big. So simply we scale the unit impulse response with the same magnitude here. So that's the whole thinking process. And all the mathematics is not new. For example, when we determine this kind of calculation, that is based upon our chapter 2 techniques. And we obtain such expression for the change in velocity at an initial time, and that is due to the physics. The system take the impulse, basically will change its velocity at no time. So that is the dynamics we learned. Okay, so basically here everything seems is not new, except you simply try to adopt this impulse function definition. I think this could be the only thing new today. And now I just try to help you to organize all the pieces of information together. Okay? Any questions? 2 minutes for accepting your questions. Any dummy one? No. No dummy questions. No dummy questions. No questions is dummy, I should say in that way.
So I'm just confused. Or I understand all the algebra and steps that you went through to get that, but the x dot naught, the units on that is going to be 1 over kilograms. How does that work out?
Yeah. So again, from our okay. So mx double dot, that is the initial force is provided by the force F equal to ma. F equal to ma, right? So mx double dot. So that's the initial concept. So in this way, if we do the integral on both sides, so that means the f over t equal to m times x double dot over time. So basically that's equal to m x dot and 0 from plus and whatever. So that is x dot, and so say from A to B, so A to B. Okay, so that's the initial concept here. So right now, once we have the F is an impulse, so if F is the impulse here, then basically the integrate will be equal to 1, and that simply is the area under the curve, and that by definition equal to 1. And for this case, right now you can see the impulse only activate in very no time there. So here basically is m v0 plus minus v0 minus here. When we integrate this one, the one for this case, it has a magnitude. For example, this is the force. Let me impose. This has a magnitude, say, in newtons. And this has a magnitude, say, in time. So basically, the one has the magnitude Newton multiplied with time. Okay, and for this one is for the velocity, it has a magnitude, say, length over time. Okay, and the mass is whatever the mass using n. So if you compare this one with this, basically the two units are equivalent. And not saying if we purely looking at from here is 1 over n, actually the 1 here has the unit of something like this. Okay, so that is the answer to these questions. Any other questions? Yeah, anything if you want to, because this is the key. If I wish everyone know what we're doing before I move on. You okay? Okay.